Topic 5-4, quadratic formulas. We're going to do some more. I actually, again, am going to use a lot of the calculator to bypass using this quadratic formula. And I'm not going to sing it again. If you want to see the song, look at 5-2, I think, or maybe it was 5-3. Anyway, so the quadratic formula looks like this. Negative b plus or minus the square root of b squared minus 4ac. That's meaning multiplying a negative 4 times whatever this number is times whatever this number is. All of this needs to be done kind of separately, and I did show it on these first two problems. However, if you can put the equation in standard form, find your a, b, and c, carefully plug into the formula, take the square root of a negative gives you no solution. So you do need to remember that. If you have a square root sign with a negative under here, you will have no real solutions. You'll learn in Algebra 2 that there are solutions, but they're not real. They're called imaginary. So anyway, let's look at the first one. Solve each equation using the quadratic formula and round the answers to the nearest tenth. Instead of having to work all of this, you're welcome to do it this way. But if you put it in standard form, which means moving the 6 to this side of the equal sign and setting it equal to 0, I think I'm going to start highlighting that, because you've got to remember that you're setting something equal to 0 every time in order to use the calculator technique that I've been showing y'all. So let's look at this first one. If I put in 3x squared minus 2x minus 6, oops, I don't know what that is, an L3. It should just be a 3. 3x squared minus 2x minus 6. Remember, we're using x because we don't need to use anything but x when you're putting it in a calculator. Make sure you have a 0 in your y2. Move this up. Somehow it's better up here in the light. Hope we can see those. Okay, so hit second calc. We're going to get the intersection. You want to wait and let it draw it. When you see the flashing symbols over here, it's saying, give me a minute, I got to draw. So then move it to this side, close enough. First curve, second curve, guess. You're hitting the enter button 3 times. So your first one's at negative 1.1. I just rounded to the tenths place. That's your first 0. Second calc, intersect, slide the cursor around to the other side. Enter, enter, enter. Negative 1 point, rounding that would be negative 1.8, because it's, I'm sorry, positive 1. 1.78 would round to 1.8. So your solutions for that are this. Without doing your quadratic equation, I do know it says quadratic formula. I'm just trying to teach you all some techniques to get quicker to the answer, but you do have to put it in standard form. So look closely at this one. You are going to have to say this moves to there, that side of the equal sign becomes negative, and this was a negative, so it became positive. Must put it set equal to 0 in order to put it in the calculator. This one you're going to find ends up being quite different. If you've got x squared minus x plus 8 and you graph it, look closely. Look where it ends up being. Doesn't cross the x-axis. It's hanging out way up at the top. So there is a problem that actually is no solution. Okay. Looking at this side, we're going to actually get into some practical applications. You're going to see some that have talking about throwing a ball, an object up in the path that it takes and then to reach the ground again. But let's look at this one. If you put this in standard form, which I didn't do, I just showed to use the calculator, this would move over there and this one could move over there, being 2x squared minus 16x. Don't change this because it didn't move. So that's a plus 32. If you plug this into quadratic formula, you're going to be using these, the a and the b and the c with the formula. But I didn't draw the formula because I decided you could use your calculator. You're going to discover that it only hits the line in one place. This, you'll learn later, is just one solution. Most of the ones we've been finding hit the x-axis in two places. See how this one has two? So usually there's two solutions. But because you're looking at one that just goes up and then comes back down and doesn't actually cross this x-axis at all, there's only one solution. And the solution is 4. So you probably want to put that right here, and that'd be 4. Okay, the drawing below represents the path of an object that's thrown into the air. So when you throw an object up into the air, it's going to reach its highest point and then fall back to the ground. So I've made some notes over here about things that happen in this pattern, and then formulas that we're using to answer different questions about something, an object being thrown. The object follows this path, and as the object goes up, the rate decreases. Think about that. When you see something, it's going to be going slower and slower than it first started out. After the object reaches its highest point, which would be right here, gravity causes it to fall back to the ground, and as it falls, the object is going to fall at a faster rate. So the rate would be my x-axis, like in seconds. So you would think of something going across your x, this direction is in time, like in seconds, and then this direction that created by your y-axis, because this is your x, would be height. H-E-I-G-H-T. Okay, so look at number 4. The path of ball that is thrown upwards described by equation h equals 35t minus 5t squared, where h is the height of the ball in meters and t is the time in seconds. So I kind of showed that. Seconds is moving along this direction. The height of it is going up to the highest point, and then it falls back to the ground. So this is at the point where it would be back on the ground. Oops, ground. So you need to remember that. This is important. This value is a value of where x falls to the ground. Your y would be just a 0. So that's important to know that at this point right here is when it hits the ground again. And that is, I'm going to draw a line, your x-axis. So when we get to a question like that. So how is the ball after 3 seconds? Well, if t was my time, then all you're going to do is plug in 3 for both of these, and you're going to solve for that. 35 times 3 minus 5, parentheses 3 squared. Make sure you put this in your calculator in parentheses. You're going to find the answer to be 60 meters high. We're dealing in meters. All right, after how many seconds will the ball be 50 meters high? Well, remember h represented our height. So if you put the problem in this way, we could use quadratic formula, which you'd have your a and your b and your c, but your c would actually be negative because you've got to put this in standard form. So it's going to be negative 50 plus the 35, t minus 5t squared. So you remember you have to subtract 50 on both sides. Don't combine 50 with 35. Often my students want to combine numbers, but this doesn't. This is a constant. This has a t and this has a t squared. They all have different, there's no like terms to add, so they're all different. Sometimes I'll say they don't have the same last name, so keep them separate. But yes, we've set that equal to 0. Throw it into your calculator and you're going to see it go up and then back down. And what's going to happen is it's going to be at 2 numbers. One time that it goes up to the, or it starts at this one, it's going to be in 2 seconds. It will reach that point again when it hits the other solution. Remember, you're finding the solutions when it hits your x-axis, and that actually is going to happen at, after, so this is seconds and this is height, and that one happens at 7 seconds. But again, put this in your calculator, the standard form that's set equal to 0. Plug that into your calculator and then check for your zeros. You're checking for where it hits the x-axis here and here. Alright, this one was kind of what I already started talking about up there. When is the ball going to hit the ground again? Well, it hits the ground when your y is 0. Your y is always your answer. So when you say y equals, it's always the answer. So this would be like your y. Your height is your y-axis. What you're looking for is height. So if that's a little confusing, ask your teacher, because you need to make sure you understand where to put your 0, and it is for your y. Your y-axis is your height, so that is where you're plugging it into 0 for your height. So that's where the 0 comes from. When it's already set equal to 0, keep highlighting. Whenever it's set equal to 0 is when you can just plug it into your calculator and look for where it hits these two places. It's been thrown into the air and then it's going to hit the ground again. When did it hit the ground again? This one, it actually hit the ground again at 7 seconds. And that concludes 5-4.